t equal to 0 equal to 10 divided by 1000. 10 divided by 1000. Then what is the value here? 10 divided by 1000 equal to 10 milliampere. 10 milliampere. 10 milliampere. See here, when t equal to 0, I of t equal to 10 milliampere. So inductor eప్పుడు start circuit aitadi at position 1 at t equal to 0 minus case. So t equal to 0 case, initially the inductor is charging is started. T equal to 0 minus, charging is not started. When switch is closed, t equal to 0 minus, charging is not started. For this case, by the inductance property, I of t t equal to 0 minus, t equal to 0 minus equal to I of t 0 plus, t equal to 0 plus, also 10 ampere. So why means inductance that suddenly does not change the value and the steady state whatever the short circuit condition case. So all the cases current flowing through the inductor whatever I of t equal to 0 inductance property, then here in this case 10 milliampere, t equal to 0 plus, t equal to 0 minus, t equal to 0 plus 0, the value is 10 milliampere. Next, what is the case? Next case, capacitance value. Capacitance value దగ్గర కేస్ దగ్గర మనం కనుక్కోవాలి. So next is at t equal to 0 plus, at t equal to 0 plus, at t equal to 0 plus. So what is the formula for voltage across capacitor? 1 by c integral of I dt. At t equal to 0 plus, integral of it dt, the value equal to 0. Voltage across capacitor value equal to 0. Then it means integral of I of t
matching news articles.
I of t dt equal to 0. I of t equal to 0. Since y means voltage across capacitor value is 0. For this case, from equation 1, voltage across capacitor value equal to 0 here. Voltage across capacitor value equal to 0. And voltage across capacitor value equal to 0. Inductance case, di by dt at t equal to 0. d equal to 0 value. Then here, what is the equation from equation 1? From this is we are considering that this is equation number 1. From 1, voltage across capacitor value equal to 0, t equal to 0 plus case. From 1, 1000 I of t, 1000 I of t t equal to 0 plus, t equal to 0 plus, plus 2 into di by dt by dt t equal to 0 plus equal to 0. So we know that I of t equal to 0 plus value is 10 milliampere. 1000 into 10 milliampere. 1000 into 10 milliampere means 10 into 10 power minus 3 plus 2 di by dt. Finally, after simplifying this, here di by dt at t equal to 0 minus, sorry, 0 plus equal to minus divided by 2. Finally, we'll get minus 5 ampere per second. This is the di by dt. అదే కదా మన క్వశ్చన్ di by dt amperes per second. I వచ్చింది di by dt. Next, what is the next step? d square I by dt square. d square I by dt square. Differentiating of equation 1. Of equation 1. For differentiating equation 1, 1000 di by dt. I differentiate di by dt. di by dt plus 1 by I by capacitance integrand you cancel out. Finally, I by 10 to the power of minus 6 plus 2 into d square I by d square I by dt square equal to 0. From this, at t equal to 0 plus di by dt value is minus 5. I value is 10 milliampere. Unknown is d square I by dt square. From that, then d square I by, substitute the values di by dt at t equal to 0 plus I of I value dt square equal to, substitute the values only. Separate the d square I by dt square. d square I by dt square value equal to, at t equal to 0 plus, at t equal to 0 plus, the value is minus 2500 ampere per second square. Ampere per second square. This is the problem while solving the calculate the initial values I di by dt d square I by dt square. Yes, substitution only. Di by dt value is minus 5. 1000 into minus 5 minus 5000. So I value is 10 milliampere. 10 into 10 power minus 3. So 10 into 5 10 cube, 10,000. 5,000 only here. 5,000 divided by here 5,000. And finally we'll get minus 5,000 equal to 2 d square by. So finally d square by dt square equal to minus 2,500 ampere per second. This type of problems are asking most of the cases related to initial conditions. Right, అర్థమైందమ్మా? హలో,
అర్థమైంది సార్.
okay. One more problem related to initial conditions. Laplace transform అయిపోయిందమ్మా మీకు? హలో, Hello.
Hello, sir.
Laplace
sir.
transform. Laplace transform అయిపోయిందా సిరీస్ లో? Mathematics లో.
అయిపోయింది సార్.
ఓకే, లాప్లాస్ ట్రాన్స్ఫార్మ్ నో ప్రాబ్లం. మీరు ప్రాబ్లమ్స్ సాల్వ్ చేస్తారు డైరెక్ట్ గా. సో మళ్ళీ నేను బేసిక్స్ చెప్పనవసరం లేదు కదమ్మా.
నో సార్.
ఓకే ఓకే. ఈ హోంవర్క్ చేయండి మీరు. నేను ప్రాబ్లం డ్రా చేస్తాను, సింపుల్ ప్రాబ్లం. సో క్లియర్ చేస్తున్నాను డ్రాయింగ్. This is a question. So calculate which s is closed at t equal to 0. Determine I of 0 plus di by dt of I di by dt when t equal to 0 plus case, and d square I by dt square. Same thing as the previous problem. So the RL circuit, calculate the I current I and di by dt and d square I by dt square when t equal to 0 plus k. So very simple here. What is the current equation of an RL circuit and supply DC voltage? V by R, already derived equation. V by R 1 minus e power minus R by L into T, already derived in first starting unit of this unit. When in this case I of 0 plus case, I of 0 plus case, inductor is when switch is t equal to 0 case, t equal to 0 switch is closed case. 0 case, this is inductor is short circuit. Inductor is short circuit, and we are considering case, this is generally when what is the current point, because I have 0 plus case is 0 value. Then di by dt. So I equation is known, differentiation of I will get one equation. Substitute t equal to 0 plus, then we'll get the di by dt equal to value, di by dt value. Then again di by dt equation differentiate, we'll get d square I by dt square when t equal to 0 plus, we'll get one value. The answers are I of 0 plus is 0, I of 0 plus is 0, di by dt is v by L, di by dt v by L, answer. V by L, d square I by dt square, d square I by dt square equal to minus VR divided by L. L square, sir. L square. So what is the current equation? Already derived current equation. I equal to V by R. First topic of derivation. RL circuit. This is a 1 minus e power minus R by L into the equation first. When t equal to 0 plus case, t equal to 0 plus case, okay, the value is 1, I of 0 plus value equal to 0. I of 0 plus value equal to 0, that is first case. Then if you are differentiating di equation, we'll get di by dt, then substitute t equal to 0 plus, then we'll get answer. Then d square I by dt square, again differentiate di by dt, we'll get d square I by dt square, substitute t equal to 0 plus, we'll get